Okay, let me do it. Go to the file, new, and University Program of VWF. We set that's okay. And here we go to the edit. At first we are going to set the end time to 116, you know. And again we set our nodes. We go here, node finder, listen like a previous one, that's why I do it very fast. Add the node and output input, okay, and again okay, and you can find the input and output here. You can see that here is the input, the output, okay. So just we select our input, for example 20, it's up to us actually, and for example this one 40, okay. Also we can do the different things. For example for the R we can do it as a random, okay. We select as a random manner. You can see this is the random manner, so it's up to us actually. And we didn't change the Q and Q bar because they are output. And let me run it with this symbol, run functional simulation. And also from here you can go the run functional simulation, it's the same, but I prefer the toolbox. Ask me to save the waveform, you say okay, save it, and you can change the name, but I don't like to change it, just save it. And this is the logs of our simulation flow. You can see the name of our project, simulation flow window is a logs of the simulation, and we reach to our output, okay. As I told you, this window is different from this window, okay. And if you check the title of this window is the read only, it means that this is the output, you cannot do anything here. So you can see based on this input you can find this output. For example, if S and R is something like this, your output will something like this. Or for example if S is 1 and R is 1, so it will be 0 and 0 for Q and Q bar, okay. So when it's finished, I close my Quartus and I open the new one, okay. So let me go here. So this is the SR lab6 SR, okay. So for the next one, for example, you are going to go to the next one. You should open the Quartus again, okay. So again, for my next part we should go to the file, new project, and do everything again and again. But I write the code before, that's why I just open the project and show you what's the result. So I open the Quartus. So we did the SR latch, and let me check the next one, D flip-flop. D flip-flop has two input, D and the clock, actually the one input and one clock and one output. And this is the code of D flip-flop. Again we have a module, the name of the module, and something like this. Let me explain them in the code. I write the code before, that's why I just open it. Now you know how to open the Quartus, how to open the file, Verilog file, and something like this. Okay, you can check that. If you check it here, the name of my project is lab6 DF with the capital D and capital F, and here the name of the module is the same with the capital D and capital F, okay. And they are my input and output, and you can see my input is the clock and D, and my output is Q, and Q is the register as well. And always condition, we just check the positive edge of the clock. If you remember, with positive edge of the clock we check, for example this is clock, the positive edge of the clock is this area, and this is the begin and end, and we assign, it's number locking assignment, assign this one to the Q and end module, okay. Again we are going to run it, and with this button we run it. This is the logs of the running. I know this lab sheet is a bit long lab sheet, and because I think it's more than 15 videos, but each video is a 5-minute only. I decrease the time of the video because you can download it very fast.